In today's lesson, we're going to learn how to interpret and sketch graphs. So let's take a look at this first example, and we're going to interpret the graph here. So we notice that our independent variable is time, our dependent variable is depth, and this graph is a scuba diver's dive. So let's answer the questions at the side here. How many minutes did the dive last? Well, if we look at the time on the bottom, each line counts for 2 minutes. So it looks like the dive lasted a total of 30 minutes. At what time did the diver stop her descent? Well, it looks like the diver dove down to a depth of 20 meters, and it looks like at about 10 minutes is where she stopped her descent. What was the greatest depth the diver reached? Well, looking at the graph, the greatest depth the diver reached was 20 meters. How many minutes did she stay at that depth? Well, she stayed at that depth from 10 minutes to 14 minutes, so for a total of 4 minutes. Okay, in the next example, it says each point in this graph represents a bag of popping corn. Explain the answers to each question below. Which bag is the most expensive? Well, notice again, my independent variable is the mass, my dependent variable is the cost, and which bag is the most expensive? Well, it appears that bag C is the most expensive. Okay, and what does it cost? Well, each line counts $1, so it appears that it costs a total of $7. Which bag has the least mass? Well, the least mass looks like it would be bag B. And what is that mass? Well, it is somewhere between, it sees every 2 lines is 200, so that's looks like it's halfway in between 4 and 6. So it would be approximately 500 grams. Which bags have the same mass? Well, bags D and E have the same mass, and that mass would be 1,800 grams. Which bags cost the same? Well, the bags that cost the same would be the bags that are in the same horizontal line, and that would be bags A and bags E, and they cost $4. Question E says, which of bags C or D has the better value? Well, if we look at bag D has more mass and it's less money than bag C, so bag D would have better value for its money. Okay, in this next example, we're going to describe the journey of a day trip from Winnipeg to Winkler, Manitoba. And it tells us here that the distance from Winnipeg to Winkler is approximately 130 kilometers. So the first section, we're going to look at section O to A. And if we look at the graph goes up and to the right. So as time increases, the distance from Winnipeg also increases. I'm just going to write a short form there. So it looks like for that segment of the journey, in 1 hour, the car leaves Winnipeg and it travels approximately 60 kilometers towards Winkler. In section AB, the graph is horizontal. So as time increases, the distance stays the same. And it looks like in this graph, the graph stops for approximately, so the car stops for approximately 15 minutes. In segment B to C, the graph goes up and to the right. So as time increases, the distance also increases. And that would be the distance from Winnipeg. And in that next, to describe the journey, the car travels approximately 70 kilometers to Winkler. In section CD, the graph is horizontal. So as time increases, the distance stays the same. And it looks like the car stops for approximately 2 hours. And finally, in sections D to E, the graph goes down and to the right. So as time increases, the distance from Winnipeg decreases. And it looks like the car travels to Winnipeg and takes 2 hours to travel 130 kilometers back to Winnipeg. So here we broke our graph up into sections, we described it, and then we actually said what happened in the actual journey. So we described the shape of the graph, and we explained what that shape represented. Okay, I want you to take a second to try this one, and so pause the video and give this one a whirl. Okay, hopefully you've had a chance to try this one. So let's take a look at section OA. And in this section, the graph goes up and to the right. So you could add, if you want, as time increases, the distance from Athabasca also increases. And in the journey, it looks like in 2 hours, the car travels 140 kilometers. In segment AB, the graph is horizontal and to the right. Oh, that's not very neat. Let's try that again. So we have let's say segment AB. The graph is horizontal and to the right. And it looks like the car stopped for 1 hour. In segment BC, graph is down and to the right. And so that means as time increases, the distance to Athabasca also decreases. And we could say that in approximately 45 minutes, the car traveled about 50 kilometers back to Athabasca. In segment CD, the graph is horizontal and to the right. And it looks like the car, since it's horizontal, the car stopped, and it looks like the car stopped for approximately 45 minutes. So 45 minutes. And finally, in segment DE, the graph is down to the right. So the graph is down and to the right. And this basically is in 1 hour. Car travels 90 kilometers back to Athabasca. Okay, I hope those are clear to you. Okay. All right. Again, pause the video and give this one a try. Okay, I'm hoping you had a chance to try this one. And let's describe the sections here again. In section OA, the graph is up and to the right. So the situation is that it looks like it was about 5 minutes. So the tub filled for 5 minutes to a depth of 20 centimeters. Segment AB, the graph is horizontal and to the right. And so that looks like from time 5 to 7, so for 2 minutes. The water is shut off. And no one's in the tub. From B to C, the graph, steep. Oh, shoot. So it says the graph, I'm just going to rewrite this again. Again, graph up and again to the right. And it's a very short time frame. So to me, I would suggest that a person sat in tub raising the depth to approximately, looks like 30 centimeters. And then CD, the graph is right and horizontal. So the depth of water stays at 30 centimeters. Then segment DE, in a very short time frame, the person or the depth changes from 32 or 30 back down to 20. So the graph is down and to the right, and depth changes from 30 to, what happened to my pen there? 20 centimeters in a short time. So I'm assuming that's when the person got out of the tub. And then from segment E to F, the graph is going to the right and it's horizontal. So this is for a short time. Graph, or depth, sorry. Stays at 20 centimeters. And then segment F to G, the graph is right and down. And the tub drains from time 18 to 24. So tub drains in 6 minutes. In our next example, we are looking at Sam, who is riding his bicycle. And it says he accelerates until he reaches 20 kilometers per hour. He cycles there for 30 minutes at 20 kilometers an hour. Sam arrives at the bottom of a hill, and his speed decreases to approximately 5 kilometers for 10 minutes as he cycles up the hill. He stops at the top of the hill for 10 minutes. So it wants us to sketch a graph of speed as a function of time, label each section of the graph, and explain what it represents. Okay, so we're going to have time is going to be down here, and this is going to be in minutes. And this side is going to be his speed, and that's going to be in kilometers per hour. And we need approximately 60 minutes here. So I'm going to go 10, 20, 30, 40, 50, and 60. So those are our minutes. And for speed, we need 20 kilometers. So I'll make that 10 kilometers. That 20 kilometers. So this is a speed versus time graph. And it says that he reaches a speed of 20 kilometers as he quickly, because he accelerates quickly to 20. So this one might be hard to draw in, but we're just going to draw a very steep line going from 0 to 20. And then he cycles at 20 kilometers per hour for 30 minutes. So 10, 20, 30. It's going to take me to about there. That's going to be horizontal line because the speed is the same. And then it says he reaches the bottom of a hill and his speed decreases quickly to 5 kilometers. Okay, so 5 kilometers is going to be right down there. So it's going to be very quick down to 5 kilometers. And he cycles at 5 kilometers for approximately 10 minutes. So he's going to cycle horizontally. That line will be horizontal for 10 minutes. And then he stops. So his speed goes right down to 0. And he stays at the top of the hill for 10 minutes. Okay, so let's label this O, A, B, C, D. I'll label this section here E, and the last one F. So from O to A, graph is up and to the right. And we'll say that in a short time, Sam reaches the speed of 20 kilometers per hour. And then from A to B, it is right and horizontal. So we could say for 30 minutes, Sam travels 20 kilometers per hour. From B to C, it's down and slightly to the right. Again, in a short time, Sam's speed drops to 5 kilometers per hour. From C to D, the graph is right and horizontal. Again, Sam rides for 5 kilometers. So for 10 minutes, for 10 minutes, Sam travels 5 kilometers per hour. Now D to E I'm not going to put in the chart because from D to E he stops. That's where the graph goes straight down. But then from E to F, the graph is right and horizontal. And that is because Sam stops for 10 minutes at the top of the hill. Okay, so again, depending on what your scale is on your graph, it might look, the numbers might be slightly different, but the general shape of the graph should be consistent to what we have here. Okay, if you want to take time to try this one, I'll pause the video and give it a whirl, and we'll take a look at it when we get back. Okay, hopefully you had a chance to try this one. So it says at the beginning of a race, Alicia took 2 seconds to reach a speed of 8 meters per second. She ran at approximately 8 meters per second for 12 seconds, then slowed down to a stop in 2 seconds. Sketch a graph of a speed as a function of time, label each section of your graph, and explain what it means in words. So let's see, in total, she took 2 seconds to reach 8, ran for 12 seconds, and 2 seconds to slow down. So she ran for approximately 16 seconds. And I think if we just count every line as 1, 2, 4, 6, 8, 10, 12, 14, 16. So this is time in seconds, and I'm only going to label every second one. Okay, and her speed was 12 seconds, so her greatest speed was 8 meters per second. So again, we're going to make every one count 2, or every 2 count 1. So there's 1, 2, 3, 4, 5, 6, 7, 8. And again, this would be her speed in meters per second. So we have a speed versus time graph. And again, I'm just going to label every second one. Okay, so for this graph, it says in 2 seconds, she reached 8 meters per second. So we know exactly how long it took her to get to 8 meters per second. And then for 12 seconds, she ran at 8 meters per second. So that's going to be a horizontal line all the way to 14. And then it took her 2 seconds to come to a complete stop. So from there, all the way down to 16 in 2 seconds. So this is a very simple graph. A, O, B, C. And in section OA, it is up and to the right. And basically the journey is in 2 seconds. Alicia reached 8 meters per second. And from A to B, the graph is right and horizontal. And she ran 8 meters per second. 8 meters per second for 12 seconds. And from B to C, the graph is down to the right. And she slowed to 0 meters per second in 2 seconds. Okay, that example is probably the easiest of the ones we've done, but again, they're all set up the same way. Okay, so there's the end of your assignment. I apologize, that was a bit of a longer lesson. Lots of writing. Hopefully you can read my writing on the screen here, and if you have any questions, please check the answers on the website.